Okay, so get this. You know how people say practice makes perfect? Well, it turns out that might be true on like a physical level.
Mhm.
We're diving into some fascinating research about London taxi drivers and how their brains actually like change shape based on their work.
Yeah, it's a classic example of neuroplasticity, the brain's ability to reorganize itself throughout life.
Mhm.
For a long time, we thought the adult brain was pretty much fixed. But this study provided some of the earliest evidence that no, our brains are constantly adapting
Right.
based on what we're doing, learning, and experiencing.
And you provided this research study. Yeah. And it really highlights just how demanding the life of a London cabbie is.
Yeah.
They're famous for their navigation
Right.
skills, right? But it's not just about knowing how to use GPS.
Absolutely. To earn the right to navigate London's streets, these drivers undergo an incredibly rigorous training program nicknamed the Knowledge.
And the knowledge is no joke.
Not at all. It takes years to complete, and they have to memorize the locations and routes for 25,000 streets. 25,000, plus all the landmarks and points of interest. They're not even allowed to use maps during the training. It's all spatial memory building up that mental map of London.
Wow, talk about pressure. So the researchers were curious, does all that intense spatial memory training actually change the physical structure of their brains?
That was the big question. They focused on two key areas, the posterior hippocampus and the anterior hippocampus.
Okay, so hippocampus, for those of us who haven't cracked open a neuroanatomy textbook lately, remind us what that is.
Think of the hippocampus as your brain's GPS system essential for memory and spatial navigation.
So did they find that London cabbies have glowing brains?
Hmm.
I'm kidding, of course. Or am I?
No glowing brains, unfortunately. But they did discover significant differences between the brains of experienced taxi drivers and a control group of people who weren't driving taxis.
Okay,
Yeah.
let's start with the posterior hippocampus. What did they see there?
The taxi drivers had larger posterior hippocampi compared to the control group.
Hold on, bigger. So all that mental mapping, all that spatial navigation, it actually made a part of their brains grow.
That's what it looks like. It seems counterintuitive, but the more those taxi drivers used and relied on their spatial memory, the larger that region of the brain became. It's pretty remarkable when you think about it. It's like their brains were bulking up, but instead of muscle, it was their spatial memory center getting bigger.
Brains over brawn, as they say.
Mhm.
But then there's the other part of the hippocampus they looked at, the anterior hippocampus. That's where things got really interesting, right?
Exactly. In contrast to the posterior hippocampus, they found that taxi drivers actually had smaller anterior hippocampi compared to the control group.
Wait, so one part grows and the other shrinks? What's going on there? Is the brain playing some kind of shell game with us?
Not quite. Remember how we said the hippocampus is involved in memory and spatial navigation? Well, it seems like those functions might be divided between these two regions. While the posterior hippocampus is more involved in using existing spatial knowledge to navigate, like those cabbies do with their mental map of London, the anterior hippocampus might be more involved in forming new spatial memories.
So the taxi drivers are no longer learning massive amounts of new spatial information about London. Once they've passed the knowledge, their brains have already done the heavy lifting.
Precisely. And the study actually found that the longer someone had been a taxi driver, the more pronounced these brain differences became. It suggests that the brain is constantly fine-tuning itself even in adulthood, becoming more specialized for the tasks we do most often.
So it's not just a one-time change. Our brains are always adapting and evolving based on our experiences, which makes you wonder, what does that mean for the rest of us who aren't navigating a labyrinth of London streets every day?
That's the million-dollar question, isn't it? This study provided some of the first concrete evidence that the adult brain is capable of profound structural change. It opened up this whole new understanding of how dynamic and adaptable our brains really are.
So it's not just London cabbies. Our brains are all shaped by our experiences. If you spend years playing the piano, could your brain look different? What if you're a professional chef? Could your sense of smell be reflected in your brain structure?
Those are fantastic questions, and they get to the heart of why this research is so exciting. It suggests we have a lot more agency over our own brain development than we might think.
Okay, before we get too carried away with all the possibilities, let's
Yeah.
talk about how they actually measured these brain changes. Did they have tiny little measuring tapes for the hippocampus?
Not quite. They used advanced brain imaging techniques. In this case, they primarily relied on something called voxel-based morphometry, VBM for short.
Voxel-based what now?
I know it's a mouthful. Essentially, it's a way to measure the volume of gray matter in different brain regions from those brain scans. Think of it like this. Imagine dividing the brain up into a 3D grid, kind of like thousands of tiny little cubes. Each cube is a voxel.
Okay, I'm starting to get the picture. So they're looking at the size of these voxels in different parts of the hippocampus.
Exactly. And what they found was that certain voxels within the posterior hippocampus were consistently larger in the taxi drivers compared to the control group, while some in the anterior hippocampus were smaller, supporting their initial observations.
That's incredible. They weren't just eyeballing it, they had hard data to back it up. So to clarify, we're talking about significant, measurable differences in brain structure.
Yes, precisely. And remember, these were just average differences between groups. Some taxi drivers had even larger posterior hippocampi than others, especially those who had been driving the longest.
So the more they used those spatial skills, the more that part of the brain seemed to develop.
Fascinating. It really highlights the use it or lose it aspect of brain plasticity, doesn't it? Absolutely. And it begs the question, what else could we be doing to shape our brains in beneficial ways?
That's what I want to know. If driving a taxi can have such a profound effect, what about learning a new language? Or playing a musical instrument? What about learning to juggle chainsaws? Maybe not the safest brain-boosting activity, but you see what I mean, right? It makes you wonder about all the different ways we might be shaping our brains without even realizing it.
Exactly. It really opens up a world of possibilities. And while more research is always being done, this study was groundbreaking in showing us just how much potential we have to influence our own brain structure and function.
So what's the big takeaway here? If our listener could walk away from this deep dive and remember just one thing, what would it be?
I think the key message is this. Your brain is not static. It's not set in stone. It's a dynamic, constantly evolving organ that is shaped by your experiences throughout your life. So embrace new challenges, keep learning, stay engaged with the world around you, and never underestimate the incredible plasticity of your own mind.
I love that. Your brain is not set in stone. It's more like clay. Or maybe one of those cool transforming robots. Okay, I'll stop with the analogies. But seriously, this has been an eye-opening deep dive. I don't know about you, but I'm feeling inspired to go out and try something new.
Me too. And who knows, maybe we'll see some fascinating brain changes as a result.
Maybe we'll even start seeing those glowing brains after all. Okay, that's all the time we have for today's deep dive. Until next time, keep those brains buzzing.